Hi, this is your host Habib Zakaria, and this is our last topology in this course, and this is about provisioning internet access for an organization using NAT overload. As I mentioned before, NAT overload is the only way to provide internet access to an organization. In this topology, we will complete task 1, which is configuring the LAN topology. We will create NAT overload policy. We will test the PC1 and see if it can access the remote or the internet PC over the internet. And we will verify if this router, which is our edge router, is going to do NAT translations for us. In a very simplistic way, this LAN topology can be expanded to a lot more switches, and the IP scheme can be increased to multiple VLANs for each floors. So you can have as many floors as you want. You can assign different VLANs to different floors, and that is covered part of the campus design network that I will be doing in the future. But for now, this will be quite enough to understand how internet access is provided to an organization. So let's start. We will start first by configuring the core switch here, and we will move on from there and go up. So this is, I'll bring up the core switch console. That's the core switch console right here. So the first thing we will do is basically we will try to do the necessary configuration, and see where we will go from here is we will assign VLANs first. VLAN 99, name we'll call it management. VLAN 11, name I'll call it first floor. IP address. VLAN 99 is actually considered to be the management VLAN of the core switch. So the core switch will have 172.20.99.1 as its IP address, and if you will add more switches, you can increment that from .1 to .2, .3, .4, .3. The reason why VLAN 99 is because it's a best practice. Instead of using VLAN 1 as its management VLAN, VLAN 99 or any other VLAN is recommended. So that's good, and let's add now interface VLAN 11, IP address 172.20.11.1, 255.255.255.0. No shut. There's one more IP I need to assign, which is the core link with the router, and that is the interface GI2/0. As you can see, I'm going to make it a routed port, and I'll assign it .2 of this network here, and that this network is our transient network. And yes, so let's do that. Interface GI2/0, IP address 172.20.10.2, 255.255.255.252. So because this is a routed port, I cannot just put an IP address, so I have to say no switch port, and I wanted you to see that actually. IP address 172.20.10.2 255.255.255.252, and I'll say no shut. Now let's verify so yes, we have VLAN 11, VLAN 99, and VLAN and the port GEC 2/0, and it has its routed port IP address. That's great. Now VLAN 99 is showing as down. The reason is we need to add another switch and give it an IP address. It's down. So let's see. So here, this interface need to be part of VLAN 11, which is the interface that's connected to, that is facing PC1. PC1 will get its network connectivity from core 1. So let's do that. And this is how you assigned a VLAN to the port. Okay. So interface GI1/1 switch port mode access, switch port access VLAN 11, no shut. So that's good. When it comes to campus network design, as you know, you have to do few important things. Number one is, the VTP mode should be transparent. There are other things we could do, like spanning tree protocol, bridge port should be, the priority should be lower, and as you can see, I mean, it's important to do those things so you understand how you can design how you can design the LAN topology. So I'm just going to add those configurations just to benefit the audience here. So a little bit of information on how to design the actual ports. So VTP mode I have added in transparent. That's one thing. The other thing we could do is you could add spanning tree mode and make it rapid PVST. That's rapid spanning tree. And the other thing we can do is we can make the VLANs, which is VLAN 11 and 99, to have a lower priority of 4096. This makes the core switch to be a bridge router or a bridge core switch. It will have its priority as 4096 from the default. So if you add any other switch on the network, those priorities are default to 32786, and because they have higher priority, they will all report back to this core switch. Okay, so that's the idea of of lowering the priority for the spanning tree. Okay, and this is again part of the course that is supposed to be campus design network, and I'm hoping to bring this course down the road. So stay tuned for those courses. So this switch is completely configured now. There's one more thing we need to do, and that is it will come up, but let's bring up the PC1 here and assign it a VLAN 11 IP address. Okay, so let's do that. As you can see, there's no IP given to this PC, so let's give it .10, 172.20.11.1. That's the default gateway IP address for this PC1. So let's see if I can ping 172.20.11.1. Now, I shouldn't be able to ping it, but I'm able to ping it because this is a simulation. Sometimes, you know, it may not ping, but the reason why it is not supposed to ping is because we did not do the IP routing here. And by adding the IP routing, I should be able to see all the routes, and also all the SVIs should be able to ping each other by adding IP routing. So this is done. I mean, the PC is able to ping the default gateway. That's what we wanted to know, and it's pinging. That's great. Now let's move to the router configuration, R1. I'm just bringing up the console here. Okay, so we have the console here, and if I do show IP interface brief, as you can see, I have three interfaces here, gig1/0 and gig2/0. So let's start configuring the interfaces here. So conft interface gi1/0. Let's give it an IP address, 100.20.190.2, 255.255.255.248, no shut. And then we have another interface G2/0, and the IP address of that one is going to be 172.20.10.1, 255.255.255.252, and no shut. Now we should be able to ping the default IP address to the internet, which is ping 100.20.190.1. Yes, I can ping it. That's wonderful. So basically the topology configuration is completed. Now we need to add the routing on this router as well as on the core switch. So let's bring up the core switch again. So let's add the default route here on the core switch. So we will say conft IP route 0.0.0 for the networks and 0.0.0.0 for the gate for the subnet mask. And the next hop IP address is the IP address of the router, which is the edge router, and that's going to be 172.20.10.1, and that's the IP address that we just configured on the router. Let's save that. Now from the core, now let me actually ping the edge router from here, and yes, I can ping it. So if I do show IP route, I should have the default static route, which is this one, as you can see. Alright, perfect. So we did that. Now let's bring up the router itself. Now when it comes to the router, there's few things that we need to do, as you know. One thing is we need to assign a default route on this edge router that will point all the traffic that's not in the routing table to the internet, right? So that's important to do. So conf IP route, and that's going to be 100.20.190.1. Alright, so that is done. There will be another route that we need to add, which is basically which will identify the internal network and the path to the internal network, right? So we need to add that. So IP route 172.20.0.0 0.0. Subnet mask is 255.255.0.0. That's the summary IP scheme of the internal LAN. So it's a class B network. That's what we are assigning. And the next hop IP address is the core of the LAN IP. That's all we needed to do here. Now this is good. Now we did that. That's perfect. The only thing now we need to do is now we are moving into this into the NAT overload configuration. So we finished task 1. For task 2, to create a policy, we need to do the following. Number 1, we need to create an access list, and that will identify the IP range of the internal LAN. So let's do that. So IP access list extended, right? And let's call it basically NAT. Okay. And here we will say permit IP 172.20.0.0 0.0.255.255. We are using the class B wildcat mask, any. And let's exit from here. Now we will add a route map. And let's call it PM policy map permit 10, right? And it needs to match an IP address. So we'll say match IP address NAT. Perfect. So we did that now. Let's exit that. Now we will have to add a statement for the overload, and we will say IP NAT inside source route map PM interface 1/0, and I'll say overload. So now we completed the configuration of the NAT overload. The only thing now we need to do is to identify the inside NAT and the outside NAT interfaces. So we know from our topology here, gig 1/0 is our outside NAT and gig 2/0 is our inside NAT. So let's start with interface G2/0, and I'll say IP NAT inside. And let's go to interface 1/0, and I'll say IP NAT outside. Now let's save our configuration. Perfect. Now the only thing we need to do now is we will test the internet PC here and see the connectivity from R1 to the internet PC using an internal interface. We will source that internal interface, which is going to be geg2/0. So let's do that. So let's ping it. Ping 10.10.10.10. That's the IP address of the internal PC. I should have mentioned that before, but I think we have been using the same IP address all along. So, and I'll say source geg2/0, and let's see. And yes, it's pinging, which is perfect. Now the other test we need to do is go into PC1 and see if we can ping it. So show IP. Let's verify we have the IP, and let's ping that outside PC. And yes, you can see we have successful results. One more thing we need to do is go into the edge router itself and do show IPNAT translations. And as you can see, I mean, we are able to get out to the internet. As you can see, we are pinging it, but the inside global IP address will always show that the which is the basically the public IP address of our router, right? It's going out as it's going out showing the public IP address, and that's what the translation is for, right? And it's going through doing its translation. These are the port numbers, and that's how it works actually. Any other PC on the LAN, if it's gonna go to the internet, it's gonna have the same IP address but different port, and it's gonna translate it. The router is gonna translate it and basically provide access to the internet in this manner. And with this, we have concluded the last chapter of this course. I hope you have enjoyed this course as much as I did, and I hope I have provided a very important and practical experience here. My recommendation is, as a homework, is to really build up your own network topology and play with the different types of NAT, which is the NAT overload. And if you look into my previous lessons, we have covered NAT static NAT, and we also did the port address translation, or the dynamic NAT. I hope I'll see you again soon in a different course. Thank you very much. Take care. Bye bye.